Welcome to aminacademy.com. In physics, let us discuss about Coulomb's law. Coulomb's law is a quantitative statement about the force between 2 point charges. When the linear size of the charged bodies are much smaller than the distance separating them, the size may be ignored and the charged bodies are treated as point charges. Coulomb measured the force between 2 point charges and found that it varied inversely as the square of the distance between the charges and was directly proportional to the product of the magnitude of two charges and acted along the line joining of two charges. Now we'll further discuss about Coulomb's law. According to Coulomb's law, the force of attraction or repulsion between two charged bodies is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Here, 2 point charges separated a distance of r meter. It is in vector form. Further detail, Coulomb's law gives an idea about the force between 2 point charges. By the word point charge, we mean that in physics, the size of the linear charged body is very small as against the distance between them. Therefore, we consider them as a point charge as it becomes easy for us to calculate the force of attraction or repulsion between them. Look at here, one point charge is Q1 and point charge Q2, both are separated distance r, then force of attraction or repulsion between them is K into Q1 into Q2 over r square. Charles Augustin de Coulomb, as a French physicist in 1784, measured the force between 2 point charges and he came up with the theory that the force is inversely proportional to the square of the distance between them, the charges. He also found that this force is directly proportional to the product of their charges, that is magnitude only. We can show it with the following explanation. Let's see that there are two charges Q1 and Q2. The distance between the charges r and the force of attraction or repulsion between them is F. Therefore, F is directly proportional to the product of Q1 and Q2. F is inversely proportional to 1 by r squared. Then combining both, force is equal to K into Q1 into Q2 over r squared, where K is the constant of proportionality, and equals to the K value is equal to 1 by 4 pi epsilon 0, where epsilon 0 is the signifies permittivity of the vacuum. Permittivity of the vacuum, then it is the value of K comes 9 into 10 power 9 Newton meter square per Coulomb square. When we take the SI units of value, epsilon 0 is 8.845 into 10 raised to minus 12 Coulomb square per Newton per meter square. According to this theory, like charges repel each other and like charges repulse each other and unlike charges attract each other. This means the charge of same sign will push each other with repulsive forces, while charges with opposite sign will pull each other there with their attractive forces. Now we'll discuss about what is 1 coulomb of charge. A coulomb is a charge which repels an equal charge of the same sign with a force of 9 into 10 raised to 9 Newton, that is that much force it attract or repulse when the charges are 1 meter apart in a vacuum. This is the definition of 1 coulomb. Therefore, Coulomb force is the conservative, mutual and internal forces. The value of epsilon 0, we know that 8.86 into 10 raised to minus 12 Coulomb square per Newton meter square, or 8.86 into 10 raised to minus 12 force per meter. A limitation of Coulomb's law. The law is applicable only on point charges at the rest. While body is moving, we cannot find the force of attraction or repulsion between the charges. It must be at rest to calculate forces of attraction or repulsion between them. Coulomb's law can only be applied in those cases where the inverse square law is obeyed. It is difficult to implement Coulomb's law where charges are in arbitrary shape because in such cases we cannot determine the distance between the charges. Therefore, we consider the charges are in point charge and spherical shape. Then we can define easily the center of that spherical is called between the two centers. The distance is called distance between the charges. If it is unshaped, it is hard to define the center of that charge. The law cannot be used directly to calculate the charge on big planets. Coulomb's law, a simple mathematical statement, was initially experimentally arrived in the manner described above. While the original experiment is established at a macroscopic scale, it has also been established down to subatomic level also. That is under R equal 10 power minus 10 meter. The Coulomb's law agrees with the Newton's third law also. That is, Coulomb's law gives the force between two charges Q1 and Q2 in vacuum. If the charges were placed in matter or the intervening space has matter, the situation gets complicated due to the presence of charged constituents of matter. So far, we discussed about what is Coulomb's law and what's its expression and limitation of Coulomb's law. And we defined also what is 1 coulomb of charge. We have done. Please subscribe our YouTube channel.